Hello friends, this is Rakhi Kaushik and today we'll be doing IUPAC nomenclature. Now, first let's see how to present the structure formula. Now this is meth, eth, prop, but, pent. So it's a structure of pentane. Now the first structure is the expanded form where each bond is shown. So we have meth, eth, prop, but, pent. So 5 carbon, a chain of 5 carbon which are joined by hydrogen. Now one thing is very important in organic chemistry, that each carbon should be bound to 4 bonds. Otherwise the structure is wrong. So this is the expanded way. Then next is the condensed way. Now this is the same structure as the previous one, but written in a different way, in a condensed form. Now this structure, the second structure, can further be condensed this way. Now when we write CH2 whole bracket 3, it means there is a chain of CH2, CH2, CH2 3 times. Sometime if we want to show the structure like this, we can write CH3, CH, CH3, CH2, CH2, CH3. Now if I want to extend this, it will be CH3, CH. Can you make it out? CH and then the CH3 in the bracket. It means this is a side chain. And CH2 2 times. It means CH2, CH2 and then CH3. And this is the bond line formula of the same compound. Now each point is a carbon here. So meth, eth, prop, but, pent. So 5 carbon are there. Now in this structure we take it as like the valency of carbon is complete. So if this is a carbon, it means it is bonded by 4 bonds. One this bond, one this bond, and one with this hydrogen and other below hydrogen, which we don't show it. So this is the way we represent the structure formula. Let's come to the nomenclature. Now whenever we start naming a compound, we should always first focus on the word root. Now what is a word root? Basically word root tells the number of carbon in the longest chain. If it's an alkane, we find out the longest chain and we make sure that the longest chain should contain the functional group. Or if we have a double or triple bond, and it should have a maximum substituents. Now if we want to cover up the functional group for double or triple bond and our chain is not longest, it's fine. We give priority to functional group double and triple bond. So the word root contains the longest number of carbon chain that should contain the functional group, double and triple bond, and it should have a maximum substituent. It means in one case if we are having a 3 small or 3-4 small substituent, and in other case we are having one big substituent. So we'll prefer 3-4 substituent more as compared to one big substituent. This will be clarified when we'll do further nomenclature. Now when we name it, how we name it, we just count the number of carbon. So if it's 1 carbon, we call it as meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex. This way we go on. Once we are done with the word root, then we look out for the primary suffix. Now primary suffix, we just look out whether all are single bond. If all are single bond, we write "ane". If we have a double bond, we write "ene". If we have a triple bond, we write "ine". If the number of double and triple bond are more than 1, then we always specify the number and position. For example, we write 2, 4, di-ene. So 2, 4 means the double bond is at, one double bond is at 2 position, other double bond is at 4 position. And di means there are 2 double bond, and ene means double bond. So this way we make sure we specify the number and position of double and triple bond. The secondary suffix take care of the functional group. Now we have a list of functional groups, so you should know the name of the functional group and what suffix we use for each of them. For example, when we have OH as a suffix, as a principal functional group, we write ol. For aldehyde, we write al. For acids, we write oic acid. Now, OH group, when it is used as a prefix, we use it as hydroxy. But when it is used as suffix, we use ol. Now when we just look out for the functional group, we specify the number and position of functional group the way we did for the primary suffix. Then we follow a priority order. I'll show you the list of priority order which you need to learn. Now we give the highest priority to the functional group, or we can say we give the lowest number to the functional group. And if we are confused about the number, then we can just sum up and we can see like which side it is less, and we number from there. We start numbering from that side. So please make sure you just write the number and position, you check out the priority order, and you give lowest number to the functional group depending upon the priority order. Now once we are done with the suffix, secondary suffix, that is functional group, we look for the prefix. Now prefix are the side chain actually. We just count the side chain. Generally alkyl group, methyl, ethyl, propyl, butyl, pentyl, or it can be complex also. So alkyl group, we take it as a side chain. Halogens, fluorine, chlorine, bromine, iodine. So fluoro, chloro, bromo, iodo, we take it as a prefix. Nitro group, alkoxy group, that is ether. So methoxy, ethoxy, so we take that as a prefix. And phenyl group. Now later on I'll tell you when the functional group is directly attached to benzene ring, we call it as benzene, but when it is not directly attached, we call it as phenyl. Phenyl group. Now when we name the prefix, we always name it in alphabetical order. So it means we name ethyl first, then methyl, because E comes before M. And when we count the alphabet, we don't count di and tri, D and E, we don't consider like that. We give the lowest number. If we don't have a functional group, then we'll give the lowest number or lowest sum rule we follow while naming. Again, we specify number and position. If it's a cyclic compound, we just add the word cyclo beforehand to tell that it's a cyclo compound or it's a cyclic compound. Let's do some practice. Now this is the first compound. So we have to choose the longest chain which should include the functional group. So we can make it out. The functional group here is OH. Okay. Now if I start from here, this is 6 and 7. And if we go here, it comes out 8. So this is the longest chain. Okay. So it means we have two side chain. This is the functional group and this is the side chain. Now we start numbering from the side which give lowest number to the functional group. If we start numbering from here, we get 3 and 6. And if we start numbering from here, 1, 2, 3, 4, 5, 6. Now again we get 3 and 6. But we'll check out the priority order and we give more priority to OH group because it's a functional group. So we'll start numbering from this side. So select the longest chain. Now longest chain has 8. So 8 means oct. So write first oct. Then you can see all are single bond. So write an. Now we have a functional group at 3 position. And for OH we write ol. So write 3 ol. Always remember between number and alphabet we put hyphen. And between number and number we put comma. This is important. So at 3 position we have ol. So 3 ol. And we have one side chain at 6 position. That is methyl. So we'll write 6 methyl, oct, and 3 ol. I hope you're getting it. Now these are the for 1 carbon, meth, eth, propyl. So this is the list. You can learn it. Then this is a list of the functional group that you need to know. For the lower classes, alkanes, alkenes, alkynes, halides, alcohols, aldehyde, ketones, and carboxylic acid is enough. For the higher classes, you need to know the entire table. Now, in this, you need to know what is the name, which functional group is this? What is the functional group? Like for alcohol, it is OH. For aldehyde, it is CHO. You can write this as CHO like this also. What name we give when it is in prefix? For example, for OH, we call it as hydroxy when we use it as prefix. And when we use it as principal or main functional group, we write ol. Okay, so just learn this table very thoroughly. You can pause the video and take some time to learn it. So you can see but and 2 ol. But means 4 carbon, meth, eth, prop, but. 2 means at 2 position we have ol. So 1 or 2. 2 position we have OH. You can start from the other side also. It's the same thing. Okay. When it's 1 position, then we can skip writing 1. Like if it is 1 ol, then we can write it as butanol also. We'll take it as 1. Now, for all the carbonyl group, all the functional group that contains carbon, we count the carbon of the functional group while naming IUPAC. Please keep this in mind. One more thing I want to tell you here is for ethers, when we just name the ether, the smaller group we put it with oxy. So this is ethoxyethane because it's a symmetrical ether. But if I have a methoxy CH, it's like CH3O CH2 CH3. Now in such case I'll put oxy with the smaller group. So I'll call it as methoxyethane. Okay. For esters, this methyl group, the one which is not joined to C, comes from alcohol. So we call it as methyl and then 3 carbons, so propanoid. So this table is important. You need to learn it thoroughly. Once you're done, then just try to learn this priority order. So this is the decreasing order of priority order. Why? Because when we name it to decide the principal functional group, we use it. And we give the lowest number to the functional group which comes in the priority order. Okay, let's do one more question in this. Now, if you see, if you have a question like this where you can have a longest chain of 10, now I can start, if I start from here, 1, 2, 3, 4, 5, or I can start from here, 1, 2, 3, 4, 5, but I prefer this side when we decided the longest chain. Why? Because if I go from this side, I get 1, 2, and 3 side chain. But when I go from this side, I get 1 and 2. So as I told you, the longest chain should have maximum number of substituents. So that's why we decided numbering from this side. Now, whenever you have a complex alkyl group to name, generally what we do is we just put it in bracket and we name it just like a normal compound, normal alkane, just putting "-il" at the end. For example, now at 5 position, we have this side chain. How I'll name it? Now I'll take this as a normal compound. So I'll start from here, numbering from here, 1, 2, 3, 4. At 2 position, we have a ethyl group. So I'll say 2-ethyl meth-it-prop-but, butyl. Now in place of butane, I'm writing butyl. So 2-ethyl butyl, and I'll put it in bracket. And this whole group is at 5 positions. So 5, 2-ethyl butyl, 3,3-dimethyl, and it is decane because 10. Okay, so how I will name it, is I'll just count the number of carbon in the longest chain. It is 10. So first I'll write it as dec, all single bond. So I'll write it as ane. Then I'll check out the substituent. Then I'll just check out the alphabetical order. Now this is 2-ethyl. So E comes before M. So I'll name this first. So I'll specify the position 5, 2-ethyl butyl. Then 3,3. Now 3,3 is the position, and dimethyl, di because there are 2. So we have to tell the position as well as number of substituent. Dimethyl and decane. Let's try to name few more. Now for this compound, again I'll select the longest chain. So longest chain can be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Anyone you can take. It's the same thing. So if I start numbering from here, 1, 2, 3, 4, I'm taking this. Now I started numbering from here because triple bond, we give priority to the triple bond as compared to methyl. Okay, so at 3 position we have 2 methyl group. So how I'll start writing? I'll select the longest chain, that is 4. 4 means but. So I'll write but. At 1 position I have ine, so no need to mention the position because when we don't mention it, I'll take it as 1 only, butine. Now at 3 position we have 2 methyl group, so I'll write it 3, 3 dimethyl butine. Same way we can do for the next. Now I'll select the longest chain, giving priority to the double bond. Okay, so this I will start numbering from here. So it is 1, 2, 3, 4. So at 1 position I have a double bond. So first 4 means but. we have double bond at 1 position, so ene, and at 4 position I have a phenyl group, so I'll write 4-phenyl. This is how we name it. Okay, this is some random structure I've drawn. Let's try to name this. Now in this, it's a bond line formula. This is 1, 2, 3, 4, 5, 6, 7, 8. 8 means oct. So I'll select the longest chain, which should cover all the functional group and side chain. So oct. Okay, now I can see one double bond here. Now this double bonded pair is at 1, 2, 3 position. So oct 3 ene, and I have a carbonyl group also, ketonic group. It is at 2 position, 3 ene 2 on. Okay, now I can see substituent one methyl group, one ethyl group, Cl and OH. Now for writing prefix, I'll follow the alphabetical order. So A, B, C. So C comes first. So 1, 2, 3, 4, 5, 6, 7, 8. So at 6th position I have chloro group. So I'll write 6 chloro. Okay, now next is A, B, C, D, E. E, ethyl comes. So 5 ethyl. Okay, now A, B, C, D, E, F, G, H, hydroxy. So at 7th position I have hydroxy. And what is left is methyl group. Okay, so space is less. So, I mean, you can just put up and you can write is 5-methyl. 5-methyl. Okay, so it will be 6 chloro, 5 ethyl, 7 hydroxy, 5 methyl, oct 3 ene 2 on. Okay, it's always better to write like in a single line. I hope you're getting it. Okay, now sometimes they give us the name and they ask us to draw the structure. So again, we'll follow the same thing, same rules. We'll start with word root. Now for this compound, first one, if I say hex, okay, so I'll make a chain of hex. So it's like meth, eth, prop, but, pent, hex, ene, all single bond. Okay, at 2 position I have a chloro. So 1, 2, you can take from the other side, it's the same thing. Chloro. And just complete the valency with hydrogen. So 3, this is 1, 2, 3, so 4, 1, 2, 3, 4. This is 1, 2, 3, 4, 1, 2. Basically, carbon should have 4 bonds. Okay, so I'm completing the valency with bond. So this is the structure. Now let's see second, pent 4 ene 2 ol. So I'll draw pent first. So it will be meth, eth, prop, but, pent. Then 4 ene, 1, 2, 3, 4. At 4 position I have a double bond, and 2 ol, 1, 2. At 2 position I have ol means OH group. And now I'll just complete the valency, 1, 2, 3, 4 with hydrogen. 1, 2, 3, 4, 1, 2, 3, 4. This is the way we draw. Okay, next see 3-nitrocyclohexene. Now it is cyclohex. Okay, so I'll make it a cyclic meth hex. Okay, so it's not benzene, it's alkane actually. No, okay, but it has a double bond. Ene. So I can, since they have not mentioned the position, so I'm putting double bond here. Now at 3 nitro, so I'm taking this as 1, 2 and 3. So at 3 position we have a NO2 group. So it's like 3-nitrocyclohexene. Yeah, this will be the structure. Next is cyclohex. Okay, hex first. It's cyclohex, so I'm making a cyclic hex, same thing. Okay, then 2 ene. Okay, so I'm taking this as 1, this is taking as 2. You can take any position as 1 and 2. Okay, double bond. Now cyclohex 2 ene 1 ol. 1 ol means at 1 position I have OH group. So this will be the structure. Now next is 6-hydroxyheptenyl, hept. So meth, eth, prop, but, pent, hex, hept. Okay, N means all single bond. Then ul means aldehyde group is there. So last one I'll make it as aldehyde. You can write CHO. Okay. Now 6 hydroxy. Now this is the one position. So 1, 2, 3, 4, 5, 6. At 6th position I have OH group. Okay. Now I'll just complete the valency with hydrogen. CH2, CH2, CH2. So this will be the structure. I hope you're getting it. You need a lot of practice. Now for aromatic compound, we follow the same rule. Now if the functional group is directly attached to benzene ring, we call it as benzene. Otherwise we take it as a phenyl. If I have some functional group here, it can be any functional group. The carbon which is next to it is 1 position. The next one is 2, 3, 4, 5, 6. Now 2 and 6 position are ortho position. 3 and 5 are called as meta, and 4 position is called as para position. So you can check out few. This one 3,4-dimethylphenol. Now in aromatic compound, actually you need to learn few, like phenol is when benzene ring has OH, it is called phenol. Aniline is when it has NH2, we call it as aniline. When benzene ring has OMe, O methyl group. Now Me is for methyl, PH for phenyl, and ET for ethyl. So we call it as anisole. So benzene with OMe, we call it as anisole. Okay, just go through it. You can pause the video. Same way you can say this also. This is 1, 2, 3, 4. Anyway you can take it, will come out 4. We just give minimum number to the functional group or side chain. So 4 nitro. This is, you can write it as benzamine also, or you can write it as aniline also, or you can write it as para nitroaniline or 4 nitro benzamine for IUPAC. Now you can try this one. Just pause the video and try to do it yourself. Once you're done with it, you can check out the answers. Same way for further practice of writing the structure, you can do this. Again, pause the video and try to do it yourself. And once you're done, you can check out the answers here. I hope this session helped you. Thank you so much for watching and have a nice day.